and his brother got to number 1 in that count, and his sister was number 2. Not in the same year, otherwise no. And so his brother also got the Olympic gold medal twice and silver medal once. So and they all went to Caltech, because Caltech at that point offered merit scholarship. They all won that scholarship. And of course, he is now a professor at math, and his his younger brother and sister are PhD students at MIT and Berkeley. And so his family, a story about his family appeared in Chinese newspapers. So his research area is similar to my company Forex. That's why I got a chance to invite him here. He first gave a colloquium at my department yesterday, and today I got a chance to invite him to speak publicly about math computation. Today he will talk about math computation, how do you prepare for it, and how do you enjoy it. He will show some problems. I hope that's fine with the parents and students. And for students, I hope you can have your backpack ready and pen and pencil in case you're asked to solve a problem right away. Right at the part of the talk. And now I think we'll start.
Before we start, I just like to invite the principal to give the brief welcome remark. Okay.
各位家长同学们，非常好我简单一下，就是我在北京前2年在北京做高中发海底100的，在北京的公司的老总的时候，我旁边那个小学奥数是非常热小学、中学都一样，是吧？我希望我们孩子能够参加比赛。声
音大一点。声音再大。
OK。像我们孩子们、家长们要努力，是吧？奥赛我们会做一个很好的项目，而且会推荐你们回国内跟美国比赛希望我们之中会产生好的名次，是吧？我前2天在教师大会上，大家培训会上我讲了，是吧？学校会出重奖，在论文方面，在竞赛方面，是吧？我们会用一整套的措施来鼓励孩子们跟家长们积极参加国际上的有名的竞赛，中文、数理化，是吧？我们中文学校将来也不是光是教文字，实际上也可以从数理化方面去促进孩子们对中华文化的传承所以希望你们，因为我也是数理化出身的，但是我很酷爱中国的文学中国的历史，所以我希望大家我看到那么多人都来参加，是吧？将来我们会举办一系列的讲座希望大家能够积极的参加，同时呢积极的投入这个竞赛听了以后回去有什么好的建议，家长们收集是吧？直接向我们教务长提议就是由现在新的教务长是孙雪飞老师，很好的老师改天我会抛写个 email 给大家，就是大家有什么好的建议尽管给我们意见今天呢由 ACCA 还有中地大学，我是中地大学毕业的我硕士学位也是中地大学，没有去数学系，因为那时候没奖学金，我去了物理系。OK， 好，那大家就热烈欢迎
I forgot to introduce that she's a current to be a team member of U.S. Olympiad team. U.S. team just won the second world number 2 in the most recent Olympiad. And he has been such a tradition for several years. So not only himself participates in chess tests, he's also a very good coach. So. Okay, thank you. So can everyone hear? Yes? So I have to apologize to the parents in advance. This is for the students. So I will talk to students. Yeah? So parents, welcome to listen also. But the purpose of this is to get students interested in the competition. Okay? That means, students, where is your paper and pencil? We will do a little bit of math. I am a mathematician, math professor. I cannot not do math. What is talk? No. We have to do some math. So everyone, you have some paper. Come on. Bring your backpack. We will have some math. So, everyone ready? Okay. So, let's start. Actually, I'll start by saying why should we? How many of you know who is Michael Phelps? Raise your hand. Who knows Michael Phelps? Who is this guy? Who is he? What is he?
He's a swimmer.
Is he okay? Is he swim okay? What is he?
Good. He's American.
He's American. Yeah, there are other American swimmers.
Won 8 Olympic medals last Olympics.
Yes.
He smokes weed.
He's American swimmer. How many of you students think it might be fun if you were Olympic? Would it be fun to be Michael Phelps? No.
He doesn't swim.
Would it be fun to be as good as Michael Phelps? I think. Okay. Well, nice. Everyone has their opinion. I think so. Next question. Do you know who Yo-Yo Ma?
Yes.
What does he do? Challenge. Is he okay?
Yeah, he's okay.
He's pretty good. Would it be fun to be like that coach too?
No, he has scoliosis.
Well, it depends. How many of you have heard of another guy? Name? Terrence Tao? How many of you have heard of this person? Terrence Tao? Is it not so many? Few people have heard. What is he? Does he swim? Does he play cello? He's a mathematician. So am I. But why is he so much better than me? What's special about him? Anyone know anything special about this man? That's not alone. Alone, that is not so special, actually.
Fields medal.
Fields medal. What is this?
Fields. That's like a Nobel Prize in mathematics.
Yeah, you guys have heard of Nobel Prize, right? Yeah. Nobel Prize doesn't give prize for mathematics. Nobel Prize instead for mathematics is given by Fields Institute. He is Fields mathematician. He's very good. He's a genius, actually. I was at UCLA for 2 years. When you see this person in hallways, you can see that the man can think. Just look at him, you can see that he's thinking. Would it be fun to be a genius? Okay. So I guess the main thing, I guess you already figured this out, is that those guys, Michael Phelps, Yo-Yo Ma, Terrence Tao, didn't get this good just by playing computer games, right? So, there's another analogy. So, sports, right? How many of you play soccer? How many of you play tennis? There must be more sports. Everyone must play some sports. So when you play soccer, okay, imagine that the ball is there. Yeah? There, on the ground. Do I play soccer like this?
No.
No. Why don't I play soccer like this?
No, I got it.
Because people can steal the ball away from you.
It's no use, it's not right way to play soccer. So when did you guys start playing soccer? When you were kids, right? Before going to school. And then your coach said, no, you don't walk to the ball. What did the coach say? Run to the ball, right? And this is how you do athletics. You have an objective, and you push yourself. And what is a good coach? A good coach tells you, push yourself and shows it's fun. Can anyone tell you ever to push yourself on the brake? On being faster? This is what math competition. To push yourself on the brake, to think fast. I told you there are some people in the world where if you look at them, it's not just they know a lot, the brain operates twice as fast. Do you see? I'm trying to draw an analogy. You can learn to run twice as fast. You can also learn to think twice as fast. So let's get started. Problem. Okay. Can everyone see the blackboard? I want you guys to figure out as fast as you can. 20 times 20.
400.
You guys are pretty fast. Maybe I make this harder. 19 times 21. First one, tell me about party.
399. 399.
Some people say very fast, you have to 399. Do you think they just multiply by the already? No. Actually, this was supposed to be a trick question. I didn't know there were people here who know how to do this problem. So I was hoping people would try to do multiplication very fast. Actually, the point of this problem is to illustrate math competition actually is not just learn to multiply fast. In math competition, you learn something else. In school, you usually learn problems like this, and the answer, the way to get the answer is this. And you do what you're supposed to do. It might be kind of boring. Maybe you can learn to do faster, and then you get the answer. Actually, in math competition, they ask interesting problems where it's not just that you can use what people taught you and do it faster. Math, really, real math, professional mathematicians, what they do is they find different ways to get to the same answer and understand how they are related. That's what math is. Real math is about discovering relationships between arguments. It's actually quite interesting. And now, what is this? So, relationship between what?
Numbers.
What is this? There's something called like 400 and 399. Kind of close, right? They're off by 1. So how come some people know that this is like this? Let me get a better marker. So if you didn't see this before, I want to show you. This is an example of the kind of thing you might see in math competition, and this is why it's fun. So why should it be that 20 times 20 is just one more? And yeah, just a second, I write it on the board first. 20 times 20 compared to 19 times 21. What is your reason?
The reason you can write 19 multiplied by 21 differently. You can write it as 20 minus 1 multiplied by 20 plus 1, and that can be simplified into 20 squared minus 1 squared.
So in middle school, you learn something which says, in middle school you learn that if you have something like x minus a y times an x plus a y, if you're going to expand it, you're supposed to multiply every pair, right? So you get x times x, which is x squared. You get x y, so plus x y. You get a minus yx, and you get a minus y squared. And look, they cancel, right? So the answer is x squared minus y squared. So what he did so fast is he said, look, x is 20. We already know 20 squared is 400. Do you guys know what is 1 squared?
1.
1. So it's 399. These are the magic tricks that you play in that competition. But for people who are even younger, who did not take algebra, I want to show another way to see it. Okay? Pity is people see so well. Okay. So here's another way to see the same thing without using the x and the y. Because in my opinion, there's no reason why you only learn this kind of math in middle school. We are teaching our 5-year-olds. There's no reason why you can only, why you need to wait so long. So 20 times 20, let me draw you a rectangle as a square. I draw you a square. And this I think should be understandable to anyone who just understands multiply, which don't have to be so old, right? 20 by 20, okay? What is 20 squared? What is 20 times 20 related to this thing? Area, right? Area inside. I draw you another square. 19 times 21. How do I draw the other square? I need another color. I'm going to do this. It will stick up by 1, and it will stop there. Does this make sense? So I drew you, the height is now 21, and the width This is 21. The width is 19. Do you agree that the area of the black square is 19 times 21?
Right.
Yes.
So let's see, let's compare. You see they both overlap in a lot, right? So what matters is how much is sticking out of each one. Right? I'm comparing the red square and the black square. So they have the same thing in the middle, but how much extra does the black square have? What is extra?
19.
Extra is 19, right? Because it's 19 across and 1 top, right? How much extra is on the red square?
20. It's interesting.
Extra 20. So that's why the 20 times 20 is 1 more than 19 times 21. Does it make sense?
Right.
Yeah. So what I'm trying to say is in math, you see you can have many different interpretations. This is algebraic interpretation. Right X, you write Y. This is geometric interpretation. You can explain to anybody. Okay? So now we have 1. Now we did all of this. Let's do another problem. Well, maybe first I should say context, right? Where does this come from? So there's some context. They promised that I will tell you about context. Okay, so maybe I do it interlude by telling you what context exists. Okay? Context that exists. So for elementary school, not so many. And the reason is because most people in this country don't think that elementary students can do this, even though maybe they can. I think my younger brother, who was math class champion, started doing this when he was 3rd grade. So, now, competition. So middle school, I write down the big one for middle school. It's hard for you guys to see, so I write as big as I can. Math, counts.
Okay.
Okay. Why is this the big one? This is the big one because it's essentially it's the only one that attracts lots and lots of students all across the country to participate. Now it's a national contest, right? So across the whole country, how do you make something where they keep having tournament? Well, what you do is every city has a small competition, and they pick about 10 people. Those people then will represent the city and go to state competition. Now state competition, we probably have what, maybe 200 people. And those people all compete, and eventually four go to represent the state of Georgia to go to national competition. And there they go and compete again and see who can win. And that's the end of competition. Okay? But you see it attracts people from all across the US. And in fact, they even have teams from Puerto Rico and Guam, American Samoa, all these other American territories. So why do you do these competitions? Is it just for the win? Well, actually, there's a funny thing. You guys know what Facebook is, right?
Yeah.
So Facebook, you can write some quotes, right? Is that right? I don't really use Facebook. Kids, does that have some quotes, things you like? Yeah. Facebook, can you write some quotes? I don't know. I think I saw this here. So actually, I've seen several people who went to national competition who wrote this, and they said, all my best friends I met at National Math Cup. Now, what does that mean? Does that mean they have no friends in school? No. But what I'm trying to emphasize is that why the math competition? It's because maybe you like math, you know? And maybe there aren't so many people around you who like math. And when you do these competitions, it's not just to try to beat each other. You meet other people who also like math. You cannot all win. Come on. There's something called pigeonhole principle in combinatorics. If there are 4 people from Georgia who can represent state, there's no way you all win. But there is a way. It's not, you don't have to win. You can just by competing, you can learn a lot. You can like mathematics in a country where maybe people don't really like mathematics. And let me tell you, liking mathematics can get you a lot of things. A lot of things. Actually, even if you don't become a mathematician, actually, we were just talking today. So, do you guys know what the hedge fund? Hedge fund is this thing where they manage some people's money and make more money, right? And the people who do it become very rich. So the director of essentially the biggest or second biggest hedge fund in the United States is former United States Math Olympiad competition. How many of you guys heard of this thing called DNA? You know what is DNA? What's DNA? Yeah, you first. Okay, fine. You already went. Yeah.
It's like the genes that determine what happens.
Yeah, it's a program that says what you are. So in the last 10 years, or well, last few decades, people wanted to know what is the gene structure of human bodies, right? They wanted to see, because then maybe you can predict diseases and so on. So you needed to have this thing called sequencing the genome. The genes is basically 4 letters, A, T, C, G, and this some billion long thing tells you who you are. About 10 years ago, there was a breakthrough where they sequenced the human genome. The parents probably remember this, right? This was a big deal. First they sequenced mouse genome, then they sequenced human genome. And then this is going to help lead to great advances in biology and medicine. The guy who directed this was a mathematics PhD in our subject from Oxford. And a long time before, he was also he was on the very first team that represented the United States at the Math Olympiad. So math, you don't have to stay in math, but do math now. It's a very good thing. And the competitions help make it fun. So, now we talked a bit about this competition. Let's talk about some kind of problem, some harder problem. This one was too easy, okay? So, some of you guys do sports, right? Can I have a volunteer? Student? Oh, yeah, okay, come on. So we don't have much space, unfortunately. So we try to do this. This is going to be kind of not enough space, okay? Slightly aside. Okay? Okay? We're going to do the following thing, okay? So I am going to walk to that chair. You see? You run to the chair. When you get there, run back to me, but don't pass me. As soon as you get to me, turn around and run again. Right? Back to the chair. And then back, and that's until you finish. Is it okay? Okay, very good. So, now, do you see what we just did? Yeah. Let's turn it to a math problem. Thank you very much. Thank you very much. You're a brave guy. You're a brave guy. Something else I want to tell all of you students. Have initiative, you know? This is America. In America, if you have initiative, help. So don't be shy. So let's turn what we just did to a problem. I couldn't do the real problem here because there's not enough space. But let's imagine what we have. We have me. Well, it was that way, right? So we have me here. This is me. What is your name? Brian. So we have here Brian also at the same time. Actually, you're not really that much smaller than me. You're almost my size. And over here, imagine this is a house, okay? We suppose we went 5, okay? Imagine that to this house is 1 mile. So you see why we couldn't do this, really. This is 1 mile, okay? Imagine we do the same thing. I walk to the house, he runs back and forth. Okay? How fast do you run? I have no idea. How many minutes for 1 mile? 6. Okay, how many miles per hour is that? 10. 10. He runs at 10 miles per hour. So he goes at 10 miles per hour. Maybe let's imagine I'm walking very fast. I go 5 miles per hour.
Yeah, right.
Now we do this, right? Here's the question. What is the total distance that Brian runs?
2 miles.
Oh! How far does Brian run? Okay, hey, you guys are pretty good. I'm impressed. So, okay. So, for people who haven't seen this before, what might you try to do? What might you try to do? You see this problem. If you haven't seen the trick, some people saw the trick. Some are brave. What's the first thing you might try to do? What's that? Figure out the time. Okay. Okay, so that's very good. So you, okay, well, I was going to say this one you can do in a not so clever way, but it works also, where you say, after some time, Brian hits the house and I'm really here. And then you say, okay, now the second stage is where we move to each other. Third stage, we again go here. Fourth stage, we do this. Fifth stage, we kind of add it all up.
Yeah.
But does this seem like a hard thing to do? Kind of complicated. Somebody else said, calculate the time. The answer,
2 miles.
so how long does it take me to go this mile?
Wow. No. 20. 20. No.
12
20.
minutes.
I'll write 1/5 hours
Yeah.
for me to run to the house. It's too bad that the markers are not showing. Can you see in the back? Okay, so it takes me 1/5 hours to run. Now, why is the time the only thing I need to know?
Because the time for 2 people is always the same.
Yes, because it doesn't matter that he's running back and forth to the chair. He could just be running that way, right? We could just say, I will walk, I'll take my 1/5 hours, get to the chair, and he just runs until I'm done walking. Runs the same amount of time, right? So since he runs the same amount of time, he runs 10 miles per hour. So Brian, unfortunately this is not showing well. So Brian runs for 10 miles an hour for 1/5 hour, right? Does that make sense?
Yeah.
And in order to abstract this, basically what you say, you can do it without numbers. I like math when you don't do numbers. You know, I'm running, I'm walking, he's running twice as fast. No matter how far we're going, or how long we're doing it, if he's running twice as fast as me, how much farther does he go?
Twice.
Far, right? Okay, so now this is another example of the kind of problem you might see. This is math competition for middle school type problem. And of course you see some people already have seen these. There are more complicated ones that people have not seen. But the point is, if you get used to working on these kinds of problems, you learn to think in different ways than what you're usually supposed to, right? This kind of problem is supposed to attract you to use the basic formulas in distance equals rate times time and get stuck. But if you do math competitions, you get practice trying to think of these kinds of arguments. So, actually, when does this talk conclude? Just to confirm. 1:15. Very good. Okay. So this is another example of math competition problem. Let me go on to another to talk about more math competition. Now I will talk about high school. Are there people here in high school? Yeah. Okay. Good. So the reason, even if you're not in high school, it's not bad to learn about these things now, because then you have an idea of what you can do in the future if you find this fun. So, the math competition at high school, there's no more math comp. Actually, does anyone know who runs math comp? Does anyone know who's in charge of math comp? Someone else? Yeah. Who runs math comp? Someone point at you. You run math comp. Yeah. Okay, very good. National math comp. Okay,
Number one in the state, right?
Okay, very good. We're going to talk about the high school, but maybe I'll see you someday. So, but now, do you know who runs math comp? What organization?
I think the engineering or something.
Yes, National Society of Professional Engineers. So, that's good. I have a lot of respect for engineers, and it's amazing that they do it, right? It's a great service that they do. But their focus, I think, is to make engineers, right? And that's why there's a lot of this with numbers, with calculation, and so on, which is a good thing for middle school. But once you go to high school, we start to talk about things where there aren't as many numbers. So let me talk about the group that runs the high school competition. And while doing so, I will say also a middle school competition that they also run. So there's an organization called AMC. This is not movie theaters. This stands for American Mathematics Competition. How many people have heard of an exam called AMC 8? Okay. How many people have taken AMC 8? Never. How many people are in schools where they don't offer AMC 8? That's a different question. I'm curious. Is there anybody in school with no AMC 8? Oh, these are good schools. Very good. So what is this? 8. 8 means 8th grade. It's not 8-year-old. So when you, and actually you don't have to be 8th grader, just up to 8th grader. If you're in middle school, you can do this, and they give you some problems, just like math counts, but it doesn't have the it doesn't have this structure of competing and becoming into groups with other people. You just do the contest once, and then they tell you your score. But still, it's a good thing to do because it's a good source of problems. It becomes very different once you go to high school. So in high school, maybe I'll draw my tree upside down because I don't know who can see down here. So for high school, there are now two things you can take. AMC 10 and AMC 12. How many people have taken this ever? Okay. And is anyone at the school where there's no this? That's also good. So what are these? Can someone take it and tell me what it is? Just like AMC 8, and why do they call it 10?
Harder.
10th grade. So what makes it different is that there are a few mathematics topics that they put here that they don't put on AMC 8. For example, in AMC 8, since it's for up to 8th grader, they don't expect that you learn trigonometry, for example, right? But then you can put it on these, like sine, cosine, and so on. It doesn't matter. But I said these are more interesting for a certain reason. Because here, this is the basic selection round that feeds into the International Math Olympiad. So at this level, there are about, I'll write 300,000 students who take it. Okay, so at first I thought only, because I'm actually on the advisory board for this competition. We want more to take it, of course. But let's see, let's try to put it in perspective. I think how many of you have heard of something called AP Calculus? AP calculus. Do you know how many people take that exam? That's 400,000. So they're already in the same ballpark. Okay? So actually, this is a pretty good penetration. It shows that since a lot of you guys are in schools where it's offered, it shows that basically this goes all across the US. And that's important, that it's spanning the US. Next question. At your school where you took it, did everyone in the whole school take this AOC? No. How did they choose? Who chose? Who chose? Math teacher. And now which levels of math took this contest? Accelerated. At what age range? I mean, so did it only have the calculus people, or did it have all the way, anyone accelerated at all? Everyone accelerated at all? And what do you think is the percent? I'm curious. What percent of people at your school take it? Is it 1%? No. Or is it less? More. More. Good. That's good. More. Okay, but is it like 10%? Is it like 1 in 10 people? What would you say? More. Less than 1 in 10. 1 in 20. Okay. So actually, if you look at the calculation, if you do this 300,000 times the 20 that it already got self-selected for, right? Then that means it basically hits 6 million. Okay? Does that make sense? That's why I'm trying to calculate the penetration number. I care about this because we want this to become very popular. We want students to feed into the Olympiad. So you do the factor times 20, you get 6 million already. Does anyone know the population of USA? No. It's about 300 million, right? So out of 300 million, that's about a factor of 1 over 50, right? Is that right? Yeah. Which is actually pretty good because not everyone in the US is in 10th grade. Right? There are plenty of people who are not. So this means that it really is a national competition. Good. Now from here, what happens? From here, if you do well, do you know what happens next? A. So then, if you do very well, you go to A. Does anyone know how many people take the A?
Not much.
Yeah, 15,000. Really? I didn't know that. Okay, good. I'll believe you. I was going to calculate that in reverse, and I'll show you this in a second. Okay, good. Amy, 15,000. So next question. Do you know what happens if you do very well? That? Okay.
USMO.
USMO is USMO. Actually, USA Math Olympiad. There's also a junior version now. USA Junior Math Olympiad. They are both things. And those correspond to whether you took in 10th grade or 12th grade level. This one, I know how many people take it because I have to grade all the papers. Well, not just me. We have 30 people who grade all the papers. But we know because when we go to grade these this year with the MIT, we have these 500 piles. We have to finish it all in a weekend. So, okay, while I do this, I'm also curious. So I was going to figure this number out backwards. And this is another thing of like mathematical sense. So maybe it will not be right, but we'll see. If I didn't know that number, I'm just asking students, what would be a logical way to guess what should that number be? So should I just take the average of the number 500 and 300,000 and say probably 150,000 taken? No, because the idea is, if it was that way, then to qualify for the first one, basically 1 in every 2 people will make it, right? And then the next one, basically no one will be very, 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 very lucky to make it, right? So what I'm trying to motivate, see, whenever we talk about competitions, you cannot help but talk about math also. There's a different kind of average you can take. You guys are used to the average where you take 2 numbers plus and divide by 2. There's another average I want to try on. Can someone think of, I heard some words?
Wait.
Geometric mean. Geometric mean is the number such that if you took that fraction of this and then took that same fraction, you get to 500. I'm just curious. I want to know if this is the same. So I'm sorry if it's not, but I want to know. What's the geometric mean of these 2 numbers? How do you calculate geometric mean? Take square root of the product of 500 times 300,000. That's a lot of zeros. So let's try to simplify it. I guess 1, 2, 3, 4, 5, 6, 7 zeros is not convenient. So I will make 6 zeros times 150. Is it okay? Mm-hmm. Is that okay? This is the same. Good. I'm approximating. Square root of 150 is like what? 12. It's about 12. 144 is 12. So I would guess 12 times 10 to the cube. Not bad, right? So this shows, use some math sense also whatever you do. Then you don't have to remember everything in the world. Okay. But then what? So actually what I want to say is as you go through here, problems also become quite different. These are calculated. These are calculated. Has anyone taken this? You taken it? Hey, very good. Which one? Okay, very, very good. So these are kind of different from any question you ever saw in high school, right? These are proof. You're supposed to prove that something is true, not just calculate. Maybe I'll give an example. I don't think we have time to actually show the proof, but as an example, actually I'll give you an example of a problem that's too easy to be on this, but gives you a good flavor of what you might need to do. How many of you guys have heard of square root of 2? That's number 1.414. How many people know 100 digits of square root of 2?
Oh.
Good, it's a waste of your memory, don't remember it. So is remembering 100 digits of pi. Anyway, so square root of 2 is what you get, you multiply by itself and get 2. How many of you guys know what is a rational number? Yeah. What's a rational number?
My math teacher says it is a ratio of two integers a over b, where b is not equal to 0. The decimal equivalent is terminates solutions.
That's correct. Yes, yes. So basically, the important thing about rational numbers is a ratio. You took two integers, two whole numbers, divided them. But better not divide by 0, we say.
Yeah.
Otherwise, it's probably not rational. Actually, it's probably not a number. So, rational number. Do you guys know that square root of 2 is not a rational number? Yeah. That you can't find. It's not like 5 over 6. That's why they write it as square root of 2. Actually, the proof of why it's not a rational number is that if it were a rational number, you would know it. You guys would not be saying it's like 7 over 50. No, no, no. So, but does anyone know the real proof of why square root of 2 is not a rational number? Okay. And if you're curious, we can talk about this at the end because there's not much time. But anyway, this is the kind of question you would have to answer. And the square root of 2 not being rational is considered relatively easy for this level. Good. But then what happens? Okay, so you do this. Next level. Now what happens? Somebody knows.
There's a camp.
Actually, there's something before IO.
There's a camp.
There's a camp.
Free camp.
A free camp. This is actually very important. In fact, it is the best math camp that you can get for high school. It is the best because if it is not, I'm not satisfied. It needs to be the best. It's called the Math Olympiad Summer Program.
Oh.
Summer. S stands for summer. Math Olympiad Summer Program. This, we take 55.
Oh, okay.
So I actually, if you go there, you'll see me because I am one of the people who runs this thing. So now, what is the point of this? Okay, if you do proceed one more level further, then you go to the International Math Olympiad, and that, United States, you take 6. So this year we went to Canada. So if you go there, you also will see me because I am the coach that brings you there. So